Okay, why don't we get started? So I have this is on the syllabus page of Canvas. This is the table that I used to put all of the lecture notes, the assignments, and then I have a video recording you can access after the class. I do that so people can, go back and things. So reflection one was assigned at the end of last week, and I know that some people had questions about it, wanted to know how to do it. So that's due today at 11:59. And like I said, I don't penalize people for being late, but I want people to kind of keep on with the assignments. Because next week, Wednesday, I'm going to assign quiz one. And that's going to be, another assignment. So quiz one will be on this GitHub repository that I said we're going to have. And so I actually sent out some emails to people's Illinois addresses, some invites. I don't know if people have seen them. And so if you could accept those and join that organization, this would facilitate what we're going to be doing throughout the term. So we're going to be doing three assignments in GitHub repository. If your GitHub account is like not associated with your Illinois email, then please let me know and I can send you an invite for that email. Because it works on whether your GitHub account. If you don't have a GitHub account, then of course you'll need to create one and send me an email you've associated it. So hopefully people can do that. If you don't do it for quiz one, we have to do it by quiz two because that part needs permissions. But anyways, let me show you in a minute what that repository looks like. And I'll go over what quiz one looks like next week. So I'll walk you through how to do everything. At this point, we're just trying to get people permissions, get people onboarded to that organization. Okay, so I don't know if anyone had questions about reflection. So this is sort of starting to build towards this project for this class. You could do it for a previous project if it's easier, but it's up to you. And just basically do the vision statement and the other things that it asks you to do. So whatever you need. And like I told someone before class, if we're gonna sort of build on our assignments. So ideally, we're gonna build on our assignments. So if you do quiz one, you do a vision statement. You can use that to do quiz two, which is going to be something else. Or reflection two, reflection three, and reflection four. You're going to think through this vision statement. I can't remember, I think reflection two is like technical data. And so you're going to consider that from the perspective of vision statement. If you decide you don't like your project idea and your vision statement, you can of course change focus later for your final paper. But the way I've kind of designed it is that it helps you kind of build it. So, once you've acquired the skill, you can just. Okay, so let's go to the repository. So this is our class repository as I've set it up. So we haven't done anything in this yet. Don't worry about like joining in and start doing things because not there yet. But basically, this is the structure of the GitHub. So if you've never used GitHub, and you may not have, this is a good opportunity to learn this platform. So GitHub, this is something that people use for software development, but they also use it for things like, authoring documents. There are all sorts of diverse uses for GitHub, but largely it's for software development. And it has a lot of the tools of version control, which we'll talk about a little bit today. You're going to have these directories here. See these folders, and you go through and you go inside of those. So you're going to be interested in quiz one next week, and then quiz two, and then we have some other resources in here When we do quiz one, when I assign quiz one, I'm going to go through what you have to do for that. It'll be pretty simple. But you'll have to kind of master something called a pull request. And we'll go through what those are next week, or actually maybe today, but in the next week. So this is where we're going to be. We're going to be at this URL. I'll send out an email with the URL and next week I'll do a short overview with that URL. What you'll do for this repository, when you get permissions, you'll have your GitHub account, and then what they call fork this repository. So there's a button up here, I think. This one here, it says fork, and you click fork. And what it'll do is make a copy of everything in its repository, but it'll put it on your GitHub. And then you can work independently on the project. So when I assign quiz one, you'll work independently on your quiz one, your version of the quiz one files. And then you'll commit those to your local account. And then when you're done, you will issue a pull request to this main account. And what it'll do is it'll take what's in your account and merge it with this account. And if everyone does that in the class, what we'll end up with for quiz one is we'll end up with a bunch of files with each person's name. They've all come from your own accounts, and we've been able to merge those in one directory with all the class results for that assignment. And everything is automated in GitHub. So all of the checking files, all of the sort of bringing things over and, synchronization, that's all taken care of through automation in GitHub. So you may be familiar with a command line version of GitHub, but that we're going to use the graphical user interface. And so this is just easier to use for the class. But I just want people to get used to version control. I want people to get used to working with a tool like this, which is actually pretty versatile. We can do other things, but I just want you to start off with that kind of stuff. So that's what we're going to be doing coming up. Now, what we're going to do today is we're going to do two different tutorials because we sort of got interrupted by Labor Day. Labor Day is next. As a result, I have to kind of combine these two tutorials in one session. So I'm going to put these slides, or actually these slides should be up in the Canvas. I don't have them up yet, but I'll put them up. They'll be under lecture 4 and lecture 5. Actually, I'll rename them so that they're easier to know what it is. But I'm going to go over these two tutorials, one being on GitHub and version control, and then the other will be on Markdown, which is another skill you'll use for this quiz. So let me set up the slideshow for this. And so this is, I'm going to be teaching you about something called version control for distributing. Basically what I explained to you just now, working and merging or issuing a pull request to the organizational GitHub. So when I say GitHub, the name GitHub, the name Git has a meaning, and then hub means it's like a centralized resource. So what is Git? So years ago they used to have so people have worked in these collaborative groups, and in working in a collaborative group, you need a way to sort of control access to all your resources. Sometimes you have code files, sometimes you have documents. If you have multiple people working on these things, you have to sort of seamlessly integrate each person's work without overwriting someone else's work or interfering with it. In code, it's very important to not have bugs crop up. And one way to ensure that bugs will crop up is to have people putting different things in, and then it's not synchronized and you try to run it, can't figure out. So there are all these tools that people used for versions. Well, the same holds true for like a Word. If you're sharing a Word document between 3 people, you want to know who changed what, if someone changed something, and so forth. And so you want to have all of that control. So people would try different methods, like manual methods, like marking your work, sharing the file, email, but that's really cumbersome. So people have developed these version control systems so that that process of sorting out who's contributing what is automated and it all comes together. So Git is a version of control, and Linus Torvalds, who is the person behind Linux, coined this term in 2005. So he was working on Linux at the time, and he needed to have a version control system that allowed him to manage edits through many different collaborators. You're working on this big project, you have a lot of collaborators, but they're all doing their sort of work on their own in different parts of the world, that, you know, different work styles, different teams are coming together, and you need to manage. Now, he used a proprietary tool of it. So there were tools back then that did this, but it cost a lot of money. So it was a proprietary tool you had to pay for. Now, we haven't talked about this yet, but in projects, a lot of times your limiting factor is having these proprietary tools that you have to pay for. Like, you know, something like Slack, you can have the free version of Slack, but it's really limiting in terms of how many messages you can have that are open. And so, you know, if you want to manage your team, if you really want to have like an archive of messages, you have to pay. And it's pretty expensive, turns out. So he wanted to manage development. He didn't want to spend a lot of money he didn't have. So at the time, people were using concurrent version systems. And so this was not very well developed at the time, at least as an easy to use tool. So you could use this, but you'd have to use it in some, you know, sort of very raw form. So it was an open protocol, which means that, you know, they had the system that you use, you just had to develop tools. Not in every project can develop tools for this. So, you know, but of course, fortunately, they had the Linux team, so they worked on this thing called Git, which built on top of concurrent version systems and made this something that could be used pretty easy. You know, so you didn't have to like spend a lot of time learning these, you know, obscure protocols. You could just do what we're going to be doing in GitHub. So that's what they did, and Git has been wildly successful since. So GitHub is just one version of Git. There's something called GitLab, which is also uses Git, but it's a different platform. There are all sorts of ways that you can use Git, but this is where Git comes from. So Git forms support GitHub, but it's not the only Git-based system. And it's important to remember that in Git, every directory and every computer is a full-fledged repository with a complete history and full version tracking abilities, independent of network access or a central server. So if we go back to our, if we go back to that GitHub repository, I'm showing you their directories in the repository. Now you can actually download a desktop version of it, where you can actually download that to your desktop. You can have those as directories, working directories, and then you can upload those. You can synchronize those to the GitHub, you know, server. So you can work in the cloud, or you can work on your desktop, and so, but it mimics kind of what you would do in a desktop environment. And so I have a history of Git article there if you're interested to learn more. So like I said, there's a command line tool. So if you're, well, I don't want to even get into the command line version here. But if you really want to, you can, you know, use the command line for things, but you really have to be well versed in the command line and know all the syntax and everything. So people use this, people use the graphical user interface. And so there are a bunch of resources here for further reading about Git if you need to learn more, if you want to learn more. So when I say fork, what I mean is basically you're making copies. So when I say, like, if I told you to fork a page or a book, okay, what does that mean? So that means that you would take the book, I don't know if you are old enough, I mean, you've ever done this, but you can take a book, take like page 35 and copy it using a copy machine. And you can make a copy. And you have that copy in the page, everything there is reproduced. That's basically forking a physical book. In this case, what we're doing is we're forking a repository. So what you would do is you would take that repository that I have in our organization, and you would make a copy of it. in your account. So everything would be copied over file for file. But it would copy it at the point of your forking action. So you make a fork, you have that copy, and then that copy sits there, and you can modify that copy. And it doesn't affect the main version. It just affects your copy. Unless you do two things. One is you update the fork, you refresh it, meaning that you just basically hit a button in GitHub interface, and it basically goes back to the main, the organizational repository, and it just compares everything in your copy with the thing in the organizational repository and updates it accordingly. It doesn't overwrite your things in there that you're working, but it updates. And then the other thing is a pull request, which is where you take the things that you're working on in your copy and you merge them together with things in the organizational repository. Again, it doesn't overwrite anything, it just merges it, so it makes it compares everything file for file, line for line. It says what's new here from this source, and it puts it into the main repository. So actually, most of the time it's quite seamless. Sometimes you can have some conflicts, but hopefully I'll show you as we go through quiz one. You'll do quiz one, you'll submit, everyone will submit their pull request, I'll accept it, and then I'll show you after that what it does. So I'll demonstrate that later. And so forking though is also important in open source. So in open source, forking is basically, people will take like a fork. I have a fork in the organizational repository from Chromium, which is the version of that Google releases of their web browser. And so people can take Chromium, they can fork it and make their own version of a web browser as they see fit. They just use Chromium as the template. And so, in this case, what you're doing is you're forking something and you're improving a program, or you're combining many programs together. So I could take a fork of Chromium, I could take a fork of, something else, I could put them together into a new web browser. And that would be, that's an easy way to do that. Everything is open, you get updates, like security updates or the latest sort of features from Google, and you just integrate that with the thing that you're working on. So you created kind of like a fork or a new version of this Chromium. And so, this is very liberating for projects because they can, they have a set of advanced tools that they can use to build the things that they want to build. It also makes programs compatible with others. So again, you're updating your fork. So, it is once you fork something, it's static unless you choose to update it. You're going to update it from your end, you're going to contribute things to it. But it can also get updates from the main organization. And in the case of Chromium, Google will release new features, new security updates. You can synchronize that with your fork and you can update your product. So it makes things compatible and you don't have to worry about whether your version of Chromium is very different from the ongoing version of Chromium. And it just makes a lot of the software, or in software development, it makes a lot of the project development easier. Now, forking actually makes it hard to enforce backwards compatibility. So one drawback to forking is that if you have backwards compatibility issues, it can make it hard to enforce those. And forking can sometimes, depending on the sort of the context, depending on what you do with that fork, it can either help or hinder the development of your project. So again, you can create a fork and you can have a new version of this project with different goals. So like Chromium is a general purpose web browser type tool. Say I wanted to create a web browser that's highly specialized education. I could do that by creating a fork of Chromium and then just really specializing the version. And so that helps me with in my development of this tool, because I don't have to build everything from the ground up. I already have the template in Chromium. What I need to do is modify it, make that happen. You can also create different functionality. So, in Chromium, there are different versions of browsers with different functionality. You can exclude features. You can add new features on top of what's already there and so forth. But of course, forking can also hinder development in that, you can have, it does limit you as to what you can actually do. So building things from the ground up might be better for some projects than forking something from, and it's just up to the person developing the project as to how they see, how they see a lot of these things. And we'll go over more about project development later. So forking can be hugely successful. This is an article, May the Fork Be With You. This is about, it's a short history of open source forks. So Linus Torvalds has a quote, which is kind of a circuitous quote. Every time there is a fork, and I think forks are actually good things. It means somebody sees a need and a technical reason to do something different from the standard kernel, which means if I have Chromium up on GitHub and I just have it, with an open source license and I say, make forks and go forth and make different versions of this as you see fit. So people will embrace that work, that project, because they see some value in building on top of it. So that's good. But most forks are failures. They find that the things they needed were not actually worth doing. And as a result, most stop. So forks are, I think I showed you that that project genealogy last time from Linux. And so, you had a bunch of forks that were made of this project. And some of them, get developed into highly specialized products and with different types of products. But some of them die off. Some of that is because when people make a fork and they say, okay, we have this great idea project, and we start working on it, and it turns out that maybe it isn't a feasible idea, that the goals that we have are just not compatible with the thing that we forked, or maybe, we don't really, it's not a feasible thing that people want in the world. So sometimes, you'll have great idea, you'll think everyone loves this thing, and you find out from maybe like some marketing research or just talking to people that it's highly not wanted. Nobody cares. And so that's why most forks die, because it's very easy to make a fork, but it's very hard to maintain a fork. It's very hard to find a purpose for the product that you're building. This also holds true of the things you build. That you have to be, when you build something, that there has to be some goal, some purpose in terms of who's going to use your product, who's going to sort of benefit from it, and these sorts of things. So, but sometimes also in projects, you have problems with collaborators themselves. So sometimes people don't see eye to eye on things, and they decide that they don't want to pursue the project anymore. So a lot of forks, are based on people coming together and saying, we're going to build this project. And then later on, they say, well, I don't really have time for it, so I'm going to give up on it. So forking is, there's a lot of potential for developing projects and forks, but a lot of times these forks die for various reasons. So I'm going to talk about version control and distributed working. It's sort of going over GitHub and just showing kind of how, we can work with GitHub and sort of the details of some of these jargon. So this is, if you haven't set up a GitHub account, do so. If you already have, I'm sure you're aware that, basically you go to the site, you register with your email, you get an account, and the account is structured as www.github.com, and then there's a user. That username is your account. That's your set of repositories. So now you have this place where you can fork things. So instead of our organizational account, you can fork something, and now that repository will be under your username / the repository, your username / project manager. It'll be your own repository where you can work locally unless you issue a pull request or you update it. It's a separate thing. And so each repository, if you have like a front page to GitHub, you'll have these, oftentimes you'll have these cards which you can put at the top of your profile these are like the most popular repositories, so you can advertise, the repositories that you want people to really pay attention to. So sometimes if you're like, trying to get a job, you might advertise the projects that you worked on by pinning them to the top of. And so people can go there and say, oh yeah, this person worked on this project, and they can just go look. And so that's one benefit of having these pins. So that's a feature of GitHub. They also have this little index here, which is like the number of contributions you made per day throughout the year. So this is one of these dashboards, which we'll talk about later. You have, indicator of how much you've been contributing to different, to your own repository. So it's another feature of GitHub. But each of these cards that I was talking about before is a single repository. So this links to a single repository. We saw a repository example earlier. Each repository typically consists of a README file, which is a file where you kind of describe what's in the repository. There are subdirectories, which means that you can create directories of files that you can name, so you can organize your repository into different themes or categories. And then additional tools for, checking files, all sorts of this stuff we'll get into in the class that kind of is incorporated into GitHub. And so this functions as a project showcase and as a server for works in progress. So you can use your GitHub repository in a number of ways. In this class, we're going to be just using, learning the basics of a repository and working on, how you can use that for projects. And so what is version control? And I told you a little bit about version control, but this is a nice graphic, I think, that kind of tells you or gives you a good idea of this in visual form. So this destination branch is the place where we will put, this is like the organizational repository I told you at the beginning of the class. This is a symbol for fork. So you can see that it's like you have this fork, and then this is your account. This is your repository that you fork. So when you fork something off of the organizational repository, it creates a new place. And this is something that you will contribute. So you notice that the destination branch is the way they would phrase this is basically the organizational repository. I can make commits to this organizational repository after you fork it, and you won't necessarily see those changes unless you refresh your fork, because it's a separate thing. Likewise, you can commit things to your branch or your own account, the fork in your own account, and I won't be able to see those in the organization repository. Okay, so that's all that's how they run in parallel. Now, when you're done with your contributions and you want to show something to me, you would issue something called a pull request. And the symbol for that is in inverse fork. So it's bringing things back together. And so that means that you're going to then issue it's almost like a form, and you're going to say, this is what I've contributed to this repository. And then you can see there's a dotted line that goes back up to the organizational repository so that I can compare changes and I can accept it. So now your work that you've done in parallel and separately can be committed into the main organizational repository. And then it can be incorporated, and then everyone's work eventually will be incorporated. And then we have this collaborative repository with multiple contributions. Now, this just shows one fork, but imagine if you had a team of 30 people and they all made forks. Typically, they don't do everyone's thing, but you can imagine how unwieldy that would be if we didn't have automation. So, there's a lot of automation here that, compares files and, indexes things. And all you're doing is kind of using the graphical user interface to tell, and basically telling the person in the organization what you've done. Now, that being said, communication is an important part of this, because you have to tell me what you've done, and I have to tell you kind of what things are repository with the README. If I don't tell you that in the README file, or you don't tell me in a comment once you've changed, then this whole system kind of breaks down because no one really knows what's going on. And that can be a problem in teams where you're using this type of version. Automation, we'll talk about this later in the class, is not enough to manage these kinds of collaborative technologies. So actually in the repo, I have this demo. So I have it set up so that there's this directory dev v prod. And you'll see it in the repository when you fork it. And what this is basically the two different, or they're different ways that people develop in GitHub. So you see this here. There's this sort of drop down that says main. And typically when you manage a repository, if you just make a pull request or you make a commit, it's committing to something called main, which is just the main place that you have in your repository, and it shows up in your directory and everything's okay. But sometimes you can create a branch. And so you can create branches for different things. In development teams, oftentimes they'll have a main, and then they'll have something called dev, and they'll have something called prod. Dev means development, and prod means production. So it might be that you have a development branch where you're working on ideas that you think are interesting, but you don't want to push them directly to, it's kind of like the forking, but it's using branches. And so you might say, this is an interesting idea. We don't want to put it in the main repository because we don't want people to see it necessarily. We want to create our own kind of alt repository where we can, work this idea out and then push it to this main fork later so that everyone can see. And so, that's where you're doing development. Production is where you might have like software that's in production. You don't want everyone to see that either. So you're kind of hiding that again in an alt, directory. And so what you can have is basically the system of internal pull requests in a repository where you have these different branches that have different things. And if you go, I'm not going to do that. I might do this demo, sure. So if I go here, and I go to dev prod, and I have this here main, you see I have main, dev, and prod. Now here for main, I just have this README that says, welcome to this dev versus prod branch demo. So I'm on main right now, and I'm going to go to dev. And now I've gone to dev, and it's a little bit different. I say this is in my README, the contents have changed. This is the dev. So what I've done is I've committed things to the dev branch that I've not committed to the main. And I have this message that says this branch is 21 commits behind main, which means that this is a different thing. It's in the same repository, but it's a different thing. I'm putting different information. And it's for my dev team because we are working on this super secret README file that is different than what's on the main. Now, if I go to prod, it's going to look different as well because it's just a different branch. And it says this is the prod branch. So this is the thing maybe we're going to put in production, which is the thing of developing, versus the main, which is maybe something more standard that you might have other people for. So you can manage all different versions of your repository directory using these different branches. And so what I showed in the diagram for pull requests is called a trunk strategy development. And this is what I'm showing you now is this branch strategy. They both basically work the same. It's just that there's a little bit of a technical difference. And people have philosophies on prod or on trunk versus branch development, which we won't get into right now. But this is just an example of how, you can use GitHub to manage this sort of version control. Okay. So now let's review some concepts really quickly. We have our edit history, and I talked about that before. You see this little graphic, which is where I'm committing a certain number of commits per day across the year. But this is just a proxy for this edit history that you have access to. So you have all sorts of different things that you have access to in terms of edit history. you can not only look at someone's contributions over the course of a year, but you can look at like their, how many times you've had pull requests of a certain repository, certain, different branches and how much people have been working on those. You have other types of, analytics that you can use, and then you can actually take a file and you can look at its history. So you can look at how the file has changed over time, different versions. Every time you issue a pull request or issue a commit, you're changing that file, and you can actually look at the history of the file changes. So that's something you can do as well in the repository. We'll look at that a little bit later. So this is actually an example here. This is where you have repository. This is a file called contribution guidelines. So this is in this repository that I created in this account. This is kind of like a README. I've just given it a different name, and it has this text. Now there's a button called history. So if I want to understand, like, say for example, I noticed there's a change in here or an error that I didn't notice. And someone maybe pushed something that they shouldn't have, and I didn't keep track of it in my head, which is normal because if you're working in big teams, you won't remember everything. So I want to know like where I want to trace this fault, or I want to trace this error to its source. One thing I can do, of course, is go to the history. So there's this history button, and if I click on that, I get this history of file versions. So this is where we have this markdown file, and we have these different versions. And what it'll do technically is it will save it to a branch that then gets deleted after it gets merged into this main repository. But it'll show who made the change and what the change was and what it was named. So you have all this metadata that you can use to trace back to a file or to a state. You can actually restore the original state of the thing you want. So that's very useful if you get into when you have a problem with like the automation. So the automation will usually check for things, but if someone makes an error that you didn't approve of, like in your organization, you can go back and restore that, and that clears things out. So there are a lot of ways you can manage information in teams with GitHub. So this just talks about this little branch that it creates. So it basically tells you all the information for this different version of the file. So I can view the document by clicking on that alphanumeric code, and I can look at what that file looked like, and I can restore it. So we'll get into that later. Examples of that. Branching and merging. So this is another graphic of how branching and merging work. So branching, of course, is fork, where you create a branch. Sometimes you can create you can create a branch, you can create a fork. So you're basically splitting that repository into two parts, into two versions. Then you can safely make changes to that fork or branch. You can add commits, which means you can edit it, you can make changes to it. And locally, you can just, when you make a change in your local directory, local file, you'll do something called a commit, which is basically like checking in back to the system. You say, this is my block of edits that I want to make for the session. And then it saves it to that place. And then, when you're done with your version of it, you can open a pull request, which then merges things back into the main branch or fork or repository from where we got the fork. You can also, so pull requests are a technical thing where you're merging work back into a single place. But you often, when you do a pull request, you'll open one up and you'll have a dialog box, and it will ask you to sort of enumerate the changes that you've made. So when I issue a pull request, it's not enough just to say, I'm merging these files, and you should usually talk about what you've done, what you've changed. In your, you don't want to get too verbose, but you just want to tell the person who's accepting the pull request, the changes that you. So I'm sitting in my organizational repository, and I'm accepting your pull request from, and you tell me the changes you made. I did my homework. I did my quiz. I did all the things and I'm done. And then I will see either say, I approve of this or I don't. If I approve, it just means, okay, I just, I checked it over, it makes sense. It won't interfere with what we're doing, great. And if you're doing something more complex than that, sometimes it's like, I, did this thing that we were talking about in this meeting, and another thing we we're talking about in another meeting. What ends up happening is you have this discussion. So you have this dialogue between the person maintaining the organization, like, or organizational repository that you've worked from, and you as the contributor to the project, the person who made the form. And you'll have this dialogue where you talk about like the changes you've made, and I might ask you questions. And then you might end up having to make changes. And then I review those and I might have other questions. A lot of times, pull requests aren't just simply like, here it is. Sometimes the questions will be asked. This is especially true in a lot of teams where they use GitHub as sort of a way to sort of facilitate, facilitate project management. So we might have a meeting where we report on our progress. We might assign tasks. You might work the repository and say, I'm going to do these things that I promised in the meeting. I do those things, but sometimes, they're not maybe up to the standards of the project. Or, sometimes you didn't get to do everything exactly the way we discussed. So you need to have this discussion board that is readily available to both you and the person accepting. So that's what the discuss and review is. And then merge and deploy in a software engineering context is where things are merged after the pull request is accepted. You have this discussion. It's a sort of iteration that goes on where you make sure everything is the way you want it. And then you deploy, which means you basically can, if it's code, you can put it into production. Or sometimes if it's like one of our homework assignments, then you get, it's ready to be graded. And so that's the whole process. Again, we talked about forking where you can fork something. It's just as simple as pressing a button. This repository, then there's a little graphic that shows you it's forking. And it does that to show you that it's making the copy. And then it changes the name of so the organization will be down here. And then your version of the repository. So what changes basically is the user. So the repository is the same name, but the organization names different, the account names different. And so that's important when you're making a pull request. Because often when you start a pull request, it'll ask you where you're pulling this work from and where you're pushing it to. And so you're pulling it from your repository and you're pushing it to the organization repository. And what it's doing is it's making a comparison, but it's doing this in an automated fashion. So then a pull request, you basically, there's a form for this. You go to the pull request tab, you make a new pull request. And then you have this dialogue where create the pull, it compares these changes. There's a base repository and a head repository, and it'll compare the branches. So sometimes I'll use the master, sometimes I'll use some other branch that's like, it has a different name, but it's basically comparing the repository and the branch. It's just comparing those versions. And so then it determines whether it's able to merge. In this case, it is. You push the button, create pull request. And then you open this dialog, which basically is this title. So you're going, when you issue a pull request, you're going to give it a title, finished, phase one. And then the comment will be where you have this discussion, this dialogue with the person accepting the pull request. I did what we mentioned in the meeting, and I made some changes, namely, and enumerate them. And then the person will say, yes, that's acceptable. Or hold on, I don't like number 2, better revisit this. And, then you can have a conversation. So once you have that, all of that information, and all this information is preserved, so the commentary is all preserved. So you can go back to it if you have a speak. You create the pull request, and then that's it. And it's pretty easy. Okay, so to me, the administrator, I look at this pull request when it's been filed, and I get this. Basically, I can merge it. I can hit merge pull request right away if I know that everything is okay. Or I might look at their comments and I might say, oh, I have a disagreement. So I have another dialog box down below, which just basically says, okay, I'm gonna make some comments before I accept it. So I don't have to merge it right away. I can wait until they fix what they need to fix. Then I can merge it. And that's just a permission, it's an authority, sort of an authority system, a permission step that you can, you have control. And so then you get your pull request accepted, and that's that. Now, there's this whole thing about task and issue management. We're going to do this for quiz number 2. So we're going to kind of build up to this where we talk about creating issues again. And so a lot of times when you have these conversations with collaborators about what you want to do, you'll create something called an issue. And so the issue is usually a to-do thing that you need to have, like put it into, individual units. And GitHub can handle complex issues and build issue boards, things that you can manage. But basically, these issues are going to be central to working in teams because they're going to take the to-do issue, the to-do things that you need, and they're going to sort of enumerate them, make them salient, and then you can reference them when say you're making a pull request. So what it'll do is it'll create this list of issues. What I'll do, maybe if I'm on a team and we have a meeting, we'll decide that we need a bunch of things, we need action items. Those action items then can be entered as issues. We click this button, new issue, we can create an issue. It's given its own number, so it has an identifier, and you give it a name, whatever you want. It's very standard, name, just whatever you're trying to do, and then give it a little description. But the interesting thing about issues, once they're in here, is that I can reference them in a pull request. I can say this pull request is to address issue 23. And I've created this code for issue 23. And people can go back to issue 23. They can look at what the work that you've done, and they can go back to the notes of your meeting, the moments of your meeting, and say, yes, this satisfies me. Okay. Or if there are some discrepancies, they have all of these things that they can go back to and say, okay, I'm confused about something, but I think I can clarify by looking at another issue and looking at the minutes of the meeting, kind of figuring out what we maybe forgot to mention in the meeting. So issues, pull requests, version control, and moments of your meeting, or having things documented from your meeting, and even documentation that you might write, all work together to help facilitate this collaboration. So this is why I'm making this sort of push for GitHub, and that we're going to work with it throughout the term. So we have this tracking sort of function where we can track everything. We can track specific to-do items. We can track how we've completed them, and we can track our conversations in working out the problems. So in an issue, we have this number, we have this task segment, break field images. That's just something we want to do in our project. We have, it's number 11. I have to write in here kind of what this is. And then, if people look through that and they're confused about something, they can leave another comment saying, I don't understand what you mean by this, please clarify. Or I issued a pull request to this effect, and then put a link in it. So you can manage this issue through, kind of from conception to description to the work that's performed to its completion. And when it's completed, you can close it and be done, or you can leave it open. And this helps us because these to-do issues can get enumerated and they can be kind of worked out. You have the record of what was discussed, and then you have that, so that maybe if you do this again next year, you can go back and see how you did it last year, and it helps you build expertise. And so we're going to work on these project boards where you take these issues and you put it on a board of sort of priority. So you can actually track issues from their to-do. So when you have a list of to-do issues, it's always to-do. Now, you don't want to have everything to do at once. You don't want to have 1,000 things in that category. So once you start working on them, you might move them to in progress. And then once you're finished, you might move them to done. So we'll go through this more about this sort of Kanban board model where you can move your issues around and track and review what their status is. You can also assign issues to members so you can hold people accountable. You can say, oh, yes, one of our project members wanted to do issue 7. So I'm going to assign that to them. They're going to get the messages. They're going to be in the loop. They're going to be responsible when we have a meeting. Okay, whatever happened to issue 7? Okay, that person needs to contact because that's their responsibility. So you can actually automate a lot of this accountability. You can move cards around the board to track the progress and their status. And there are other types of version control. So we're stressing GitHub in this class. There's also checking in and checking out documents, which I think technically you can do with GitHub, but sometimes if you're working with like Word docs or something, this is useful. So a lot of times you'll encounter version control systems where you will have document, like a Word document, and it'll require you to take that document, check it in, or check it out, so you can make edits, and then check it in. So the idea there is that you can have unique contributions to a Word file, and no one else has access to it to overwrite it. So if 2 people decide to work on a file at the same time, the person who has checked it out first has access to it. And then when they check it in, another person check it out. And so that file then gets, you have a record of who's contributing what, and nothing gets overwritten. These are kind of a little bit more unwieldy than GitHub, but this checking in and checking out model is a type of version control. Okay. So I think I'm going to stop there on this one. There are other things in here like cloning a software repository and other things, but I want to get to the other demo here because we'll need this for quiz 1. And that is this Markdown tutorial. So Markdown is a programming language. It's, what they call high-level programming language, meaning that you don't need to specify everything. You just need to specify syntax, some syntax for formatting and things like that. The interpreter that you'll have on GitHub can take care of rendering Markdown. So like with HTML, for example, you'll have tags that you have to open and close for different elements. And then, the web browser usually renders HTML as a series of images, a series of text formats, things. Markdown is not HTML, it's a little bit higher level. So I'm going to talk about Markdown because when you write a README file in GitHub, you're going to be using Markdown. And there are tutorials on Markdown, so if you need the specific attributes of Markdown, syntax, that's available. Well, why are we learning Markdown? So Markdown actually is, it was developed by John Gruber and Aaron Schwartz. And they developed this language because they were interested in developing something that was very lightweight for projects, for contributors to projects that didn't require a high bar of entry. So if you're familiar with like C++, that has a high barrier to entry. You have to learn C++. Sometimes you have to take a full course on it before you can even write it. Like a hello. In HTML, the learning curve is a little less steep. But with Markdown, it's actually pretty easy. So Markdown is actually something that comes in a couple of different flavors. We have GitHub flavored, which we'll be using, and then there's R flavored. So if you statistics, because it's R flavored GitHub, it just has different features to it that allow you to, if you're working with README files, GitHub flavored Markdown has features that work well in README files and rendering it in the graphical user interface. Now we use Markdown as sort of this, base high level language, and then we can add things like HTML elements and LaTeX elements and other things to create attractive technical. And that's usually what people use Markdown for on GitHub, is to create those README files. README files then need to be sort of stylized and they need to be affirmed. So this is something that's a standard thing people use in a lot of open source projects, but can be useful in other contexts as well. So basically Markdown works very much like HTML. It yields the same sort of outcome as HTML. So I have this demo here where I have these two set, I have these pairs of things, header 1, header 3, and then this table. And the question is which things are written in Markdown and which things are, because you can't tell immediately from one. And as it turns out, the first header 1 was written in Markdown. The second header 1 was written in HTML. And basically the difference here is we have this little tag, this little pound sign that makes header 1, H1 header HTML. So in HTML, you open and close our header 1 text with this tag. In Markdown, you just have a single symbol axis. And so this is, maybe a little bit trivial, but it's very similar to HTML because it's a Markdown. Or it's a markup language. So it has these same attributes. Markdown is just a little easier to use because once you start getting the hang of it, it's a lot easier to use in a very, sort of cursory way. You can also build tables in Markdown that are, this table is built in Markdown. An HTML table involves, having the different rows and the different columns specified, and you have to use specific commands. In Markdown, you just basically draw a table with pipes and with dashes, and then you put the text in the cells. So if you have people in your project who have different levels of coding ability, using Markdown as sort of the common language is always good because it kind of appeals to people with a lot less technical skill. So that's why a lot of people use it. So there are a lot of formatting tricks to Markdown. You use line breaks a certain way. You build tables a certain way, which is much more intuitive than what you would do in HTML. And so you can build bullet lists. So a bullet list is built in HTML by specifying the UL element, and then each line is specified open and closed. The bulleted list is, a paragraph. You have to remember all of that. And of course, if you know HTML well, it's trivial, but if you have a very low technical skill level, or if you're not familiar with HTML, a lot of people aren't, then this actually works better because in Markdown, you're just basically bulleted list, star egg, star milk, star cheese, and it just renders assembly to HTML. So we'll talk about this where, there's a barrier to entry. So sometimes it pays to have a lower barrier to entry, especially with technical things. And GitHub actually is an example of that because, we could work on building our own version of the ecosystem. The barrier to entry there is very high because you got to build it yourself. With GitHub, you have all the tools available to you, and you just need to learn the graphical user interface, and the automation takes care of like the others. And it's similar with Markdown because Markdown is rendered in HTML and it's rendered in GitHub's graphical user interface, and it just makes it easier to kind of put the commands in and get what you want. So there are all sorts of Markdown tutorials on the web. There are ways to master this, so I'll leave you to that. But when we go back to the README file, we can create these technical documents that not only use Markdown, but they also use things like HTML elements. So that's another thing about Markdown. It's not only lowering the barrier to entry, so you can have people with very tenuous technical skills, contribute to your project, but you can actually add in those elements anyways. So this is a sort of a thing that I've written in Markdown, but also with HTML and LaTeX. And this is what it looks like rendered. So it kind of looks like an HTML document. But as it turns out, I've actually combined all three of these things. So I actually have some Markdown in here. I have some HTML, So the markdown is line 12. The HTML is like lines 3 through 10. And then the LaTeX is 14 through 16. And that's just rendering the equation, but it all kind of works seamlessly in GitHub flavored markdown. There's this article from our bloggers. This is using our flavored markdown. So, you can use markdown for README files, and that's of course what we're going to be doing here in class. But you can do all sorts of things with markdown. One of those is you can create a book manuscript using something called bookdown. So you can take people have taken markdown and created a new version of it called bookdown. It's a specialized markup language where you have markdown as the base, and then you include specific functionality for edit for formatting book. So it has specific commands that are specific to bookdown that can be run in R flavor. So, this is something that people have worked on. So you can do a lot of things with markdown that, don't require a lot of technical overhead, can be quite useful in projects. Another thing you can build, like, we're talking about README files. README files are front doors to your project. You put them prominently in your GitHub repository. Another thing you can do, of course, is build reproducible documentation. So this is, again, using R markdown. This is a group where they're building documentation for statistical analysis, as one does with R. And it allows you to integrate things like Python and SQL into the document. But basically, what you want to do is you want to create this documentation that people can access, people can change without too much technical overhead. And you also want it to be a pipeline that people can go back to again and again and reuse it. So I can build a pipeline of tools that's very obscure that only I know how to use. I could use like, I don't know, C# and HTML, and then maybe some, ancient thing that only was used on Mac OS, but like not the Mac Silicon. So that would not be a good set of pipeline choices, because only I can really use that. What you want to do is you want to have tools where anyone can pick up a pipeline of tools and use them and critically get the same consistent output across users. And that's very essential in the project. So people have worked on this sort of reproducible pipeline for documentation. And that's another reason why Markdown was useful, because you can actually build these kinds of tools. And people don't have to be, have a high level of technical expertise to use them. So, Markdown has its pros and cons. It's long-lived. It's been around for 20 years. It's versatile. So it's a lightweight markup language. And so this is the kind of thing you're going to do in projects. You're going to make these pro and con lists about any tool that you use. So when I introduce a tool, I'm not really advocating. Sometimes I'll mention the pros and cons. But really, if you make a choice on a project, there'll always be pros and cons. You might have something that's really a positive thing and something that might be a negative. So Markdown will use that as an example. So Markdown, of course, as we mentioned, it's very lightweight. It allows you to do formatting. It doesn't require a lot of symbols or anything like that. So you can have contributors who are very technically unsavvy, and they can use Markdown. They can learn it pretty quickly and apply it to the project. Now, the problem, though, is that it's not standard, and many flavors are not cross-compatible. So, for example, if I built something in our flavor Markdown, I can't necessarily render it. A lot of times I'll build, they'll have these interactive notebooks. And when you put an interactive notebook on GitHub, and they're built in a combination of different programming languages. But basically, when you put it on GitHub, sometimes it'll run. So when you use these tools in your project, you want to really evaluate them, say, what do they bring to the project? They may bring something great to the project, but there are also some drawbacks that it's going to impact our performance. We'll talk a little bit more about that in the technical lecture, but that's not for a while. Again, Markdown is a shallow learning curve compared to something like HTML, or some other lower level programming language. And again, that's something you want in your project. You don't want to spend all your time learning programming. Sometimes you have to, you're forced to do that. And that's where you can have some of these educational mentorship opportunities for members of the team. But having a shallow learning curve for a technology is good. On the other hand, in the case of Markdown, we have limited control over semantic specification of text. So when we write text in our README, we can't like have, include a lot of metadata. Now, there are other ways you can do that, integrate other tools, and that's maybe you don't want to include that. Maybe those are decisions that you have to make, but that's of course something you have to invest in aside from the basic aspects of what you're managing the project on GitHub. Markdown is also platform agnostic, so at least the basic flavor, you can use it in any sort of context where you can create a Markdown file, which is great. And that's kind of what you want for projects in general, because people have different technologies. They use different web browsers, or maybe they're working on Mac OS versus Windows or whatever. But sometimes that can introduce stylistic limitations. And so with Markdown, we see these stylistic limitations that occur. And so again, you're choosing a very easy to use and very easy to access technology, but at a cost of having limited control and limitations in terms of what you can do with it. So that's going to be true of a lot of things that you choose in pipelines, in your project technologies. How do you implement your project? How do you do things? So you could actually use Markdown also as part of a pipeline. So right now I'm going to describe a pipeline going from a Markdown file to something where I'm going to publish documents. And the reason I'm showing you this is I want to kind of take you from a very simple sort of technological choice in your program to something you can do with. But in order to do that, you need to kind of coordinate all of the pieces. So I have this Markdown file, and I've written it, and I'm going to say that I'm going to commit it to GitHub. And being in GitHub, of course, is going to allow me to do certain things. It's going to allow me to do like document reviews. So once I have this committed to GitHub, I can have collaborators look at it. They can make changes. Because it's a relatively simple language, they can make changes pretty easily to the format, to the content. They don't have to worry about getting it wrong. You don't have to worry about going back over it and correcting things later. We might have to do a little bit of that, but that's part of the, you do. So that's a good choice. GitHub flavored Markdown, put it on GitHub, if your collaborators review it, it's pretty seamless. You can also have author collaborative documents. So if there are multiple authors, they can all commit their own Markdown into that Markdown file, GitHub, and it can be compiled pretty easily. Not too much problem because you can see where things need to be put into place. And it would be nice in Word, for example, if you're working collectively in Word document, you can put in like marks. Okay, what's here? But that's a little bit clunky and it has its own limitations. So if we were to use a Word document, we couldn't use GitHub as a collaborative. We'd have to maybe like use some other way to like review the document. And that might be very fun. So Word introduces maybe more, you can use metadata more, but you can't do a lot of it. It's not as seamless. So again, this Markdown part of the pipeline has sort of its own benefits, its own. But one thing you can do once you have your Markdown file, is you can take that Markdown after it's been modified, after people have reviewed it, and you can actually convert it to other types of documents. So you can do this, of course, on the Word file, but then of course you get bogged down in these sort of, making these changes and it's being funky. But with Markdown, of course, you can use something like Pandoc. You can create documentation in HTML. You can import this to something called Read the Docs, which renders it in a much different way than what you would have in a GitHub README file. You can actually convert it to PDF format, you can convert it to a Word document, or you can convert it to HTML. So there are a lot of options. So, you think about using something like Markdown, you also want to see what kind of downstream tools are that document. And so, using this as part of a pipeline, people have used Markdown to write research papers where you have a lot of moving parts, you have images and text and other types of notes that you need to manage, reference managers, things like that. And so you can integrate those, as you see on the right there. You have the Markdown file goes in this program called Pandoc. You can import images, bibliographies, different style templates, and you can output those in different formats. So you can produce a PDF file, a text file, an HTML file, a doc file, just by conversion. Someone wrote a book using Markdown, Pandoc on the internet. And this also, of course, also you can build reproducible documentation as well. They didn't have an article on that, but judging from the other example I showed earlier, that's possible. And then, of course, you can create beautiful semantically rich documents, not just through using Markdown, but then by using this pipeline, via Pandoc, coordinate those tools to create all sorts of things. Now, there are other tools you can use to integrate with your GitHub repo. If you're interested in using code, or if you're writing a lot of code and you want to, integrate your Markdown file with something in C++, you can do that using Visual Studio. So I don't know if people have taken 205 in this class, if you've taken a programming course. Well, usually they'll use Visual Studio Code as like a compiler, text editor, or a code editor code. And this is something that you can use like kind of on your local machine, but you can integrate this with GitHub. So you can integrate those in your GitHub repo. You can like make changes in accordance with what's in the GitHub repo, and you get the tools that Visual Studio Code offers, like editing tools and other types of things. And so there's another tool called Pulsar Edit, which used to be called Atom.io. That's something you can also use to work with Markdown files, and Pandoc is actually integrated into Pulsar Edit, so that makes that easier. There are different types of tools. There's this Mist JavaScript tools. This is where we can extend Markdown to a larger publishing strategy. And so to learn more, I have some articles here. This is the ins and outs of using Markdown for technical writing. So one thing you find with a lot of like technical takes is that people will advocate for something or against it. And so, you can get in the habit of reading these articles on why something is great and why something is horrible. And so reading those kind of polemics, you get this sense of where what kind of decision you can make. So like someone will say why you should not use Markdown, why you shouldn't use Markdown for documentation, what's wrong. So basically, some people feel that Markdown is not sufficient for writing documentation for your project. Some people say you can use it under certain conditions. Some people don't think it's wrong at all. In fact, they advocate for it. So if you read enough of these articles, you get a sense of maybe what the decision is. And so that's why, I give you these articles marked out. Just think about this for any technology that you might. What are the drawbacks, what are the benefits, and what are you doing? Don't worry about the hype or anything like that either, because sometimes the hype is, this year it's Markdown, next year it's something else. And when you have a project, you want some sort of. Okay, so I don't know what time is it here. Okay, so we're at time. I'll come back to this next time. So I think that's all for today. I just wanted to remind you again that, we have reflection 1 that we can do today, but if you haven't done it yet, please do it. And otherwise you can be late. But please get that in. And then next week we're going to have quiz 1. So let me know if I've sent you invitations to join the organization or Illinois EDU email. If your GitHub account is not associated with an Illinois EDU email address, email me and let me know that so I can invite you and write emails. So and then again, I'm going to go over our organizational repository next week, and then you'll have the links and you'll be able to start quiz 1.